Hi, welcome back to Mrs. Thompson's classroom. Today we're going to be talking about functions. So first of all, we need to remember what a function is. We're going to talk about what it means to be an independent versus dependent variable, the domain of a function, and the range of a function. And we're going to do that when we graph them to be able to find various values and intercepts. So let's get started just by defining what a function is. So a function is any relation where, okay, so we got to remember what a relation is. A relation is any set of ordered pairs, and a function is a relation in which each element of the domain only corresponds to one value in the range. Okay, in a previous video, we defined domain and range, so let's just refresh ourselves a little bit. Domain is the set of all x values. We call this the independent variable. Okay, the range is the set of all y values, and we call it the dependent variable. Okay, so x is independent because it's our input. We can choose x, we plug it in, we do a calculation, and we get an output. So the output depends upon what x was chosen. So that's why the y, or the output, is the dependent. Okay, so let's look at a few and see if we can determine what this definition tells us. How do we know if something's a function or not? Well, if each x can only get assigned one y, then if I can list the points out, I can only use x once. Okay, that makes sense, right? So in this first relation x, every x is unique. Okay, I don't have to have unique y values. I just have to have unique x values. Okay, so this one is a function because each x only occurs once. Okay, but what about in question B, in relation R, I notice that I have 2 used twice. So this one is not a function because x equals 2 is assigned or corresponds to, is assigned to both y equals 4 and 6. So the x equals 2 occurs twice. Does that make sense? Okay, now in these bottom two examples, in C and D, these are a picture so that we can get a visual of what's happening here. So the first bubble is the domain, the second bubble is the range, and the arrows show us the connections. So in example C, 2 is only assigned to 8, 3 is only assigned to 12, and 4 is only assigned to 16. So this is a function. Okay, each x is only used once. Okay, but in this one, if I check out the value of a, it's assigned to both y equals 1 and 2. Okay, notice the same thing happens with C. It's assigned to both 3 and 4. So it is not a function. Okay, it doesn't matter that C and D were both assigned to 4. I don't care that the 4 is occurring twice or connected twice. What I care about is whether the X value or the value in the domain bubble is occurring more than once. Okay? All right, so now let's take an example here. We have this chart, the year, and then the number of graduates in that year. So the independent variable is the year that we're in. It's our starting place. The dependent, then the output, would be the number of graduates. Okay, so the domain would equal all of the years. So 2010 through 2020. Okay, and the range is the number of graduates. So I have 30, 35, 36, 38, and 40. So to be able to plot this, I'm just going to draw the set of points. So the first thing I need to do is I need to change my grid. So we're going to make this first one 2010, and then I'm going to have 2012, 2014, 2016, 2018, and we'll make the very edge of the graph 2020. Okay, and then maybe we come and we go, okay, well, this is 35. And then, I can just make this, we'll go 36, 37, 38, 39, and we'll make this 40. Okay, so 41, 42, 43. So we can work our way up, okay? We can define the grid on our graphs however we want. This is why it's vitally important that we label our graphs so that they're readable. Okay, so in 2010, then I have 30. Oops, I didn't label 30, so we'll put 30 down here. Okay, plot that point. In 2012, I'm at 35. In 2014, I'm still at 35. In 2016, I jump up here to 38. But then in 2018, I'm down at 36. And then in 2020, I'm up at 40. So I have all my points. That's my scatter plot. A scatter plot is just a graph that's just dots. It's just points. They're not connected. They're just plotted points. Okay, so in order to determine if it's a function, each x can only get one y. So this means that I have to pass what is known as the vertical line test. So each x only gets one y, and that is true. So it is a function. Okay, all right. Now, function notation. Well, if something is a function, then I can write it in this way here. And we read that as y equals f of x. And the reason we write it that way is so that I can see the x and the y all at the same time. And so it just helps us with our notation. Now, in order to be a function, remember every x can only output one y. So if I have an equation and I can put in an x and get two things out, then it's not. So let's take a look at these two examples. This example A would tell me negative y squared equals 16 minus x squared, right? I can move that x squared to the other side. Then I can get rid of that negative, so I'll have y squared equals negative 16 plus x squared. But how do I get rid of this square on the y? Well, we would take the square root. But when we take the square root, how many answers do we get? We get 2. It can be plus or it can be minus. So right here, there are 2 answers, 2 outputs. Therefore, and these 3 little dots mean therefore. It's another little math shorthand. Therefore, it is not a function. In fact, this equation is going to graph what would be called a hyperbola that we'll learn about later in the year. Okay, in this second one, if I solve for y, I can move the 2x squared to the other side, and I get y equals 8 minus 2x squared. This is a singular output. There's no plus or minus. There's no y equals this or that. It's a singular output, so it is a function. And in fact, this one would graph a parabola, which you may be familiar with from algebra class. Okay? All right, so here's, remember I said earlier, I mentioned this vertical line test. So if I have the picture, I can simply take a vertical line anywhere on the picture, and I should only pass through the graph once. So this one's a function. But on the second one, look what happens when I put my vertical line right here. I pass through it once, twice, 3 times. So this is not a function because it fails the vertical line test. Okay, so that gives us a little bit of a picture of it. So if we have the graphs already, if they're given to us, we can see whether it's a function or not. Okay, so let's talk about domain. Okay, this first function is a polynomial. It has an x cubed and an x. So this one's domain is all reals. So in interval notation, we would write that from -infinity to infinity. Or in set builder, we could just say x such that x is an element of the real numbers. Okay? Now in B here, g of x is a fraction. And we know that we cannot divide by 0. So this means x squared cannot equal 4. So x cannot equal plus or minus 2. So my domain is the set of x such that x is not equal to plus or minus 2. Now if you wanted to do that in interval, you'd have to go to -2. And then you'd have to go from -2 to 2, and then from +2 to infinity. And we would join these together. Okay, because on a number line, here's -2 and here's 2, I have this piece, I have the piece between them, and then I have the piece on the right. So I've got 3 intervals. Okay? All right, when we do square roots, the square root, what's underneath, what is called the radicand, has to be greater than or equal to 0. Remember, if I have a negative underneath the square root, underneath the radical, if it's an even radical, I cannot put negative numbers there, otherwise I get i's, I get imaginary. So this would tell me 4x minus 3 is greater than or equal to 0. So when we solve that, I get x greater than or equal to 3/4. And I can write that in set builder, or I can write that in interval notation. But this would be the domain. Okay, now in D, I still have that 4x minus 3 in the radicand, so it has to be greater than or equal to 0. However, it's in the denominator of a fraction, so I cannot equal 0. Otherwise, I'm undefined. So in this case, I end up still getting the 3/4, but now I'm just greater than. And so my interval would look like this with a parentheses instead of a square bracket. Okay? So hopefully that gives you a little bit better understanding of functions, what a function is. Let's do one more little picture here. So if we're given the graph, we can find certain information. So this tells me right here that x is 1. And what I want to do is find, this is asking me to find y when x equals 1. So if I look at the graph, when x is 1, I go up and I get a y value of 3. Okay. The x-intercept, this term right here, means where does it cross or intersect with the x-axis. So on the graph, that's right here and right here. So that would be at 0, 0 and -2, 0. X-intercepts always have y values of 0. Okay, now notice we can also find y-intercepts, and if it is a function, it has to only have a unique, a singular y-intercept where it crosses the y-axis in order to be a function. But I can have a whole bunch of x-intercepts. Okay, so the domain of this one is all reals. And the range, we're assuming this graph keeps going up and down forever, and that means left and right forever. So this would also be all reals. Okay. All right, let's look at this one. So f of 1, in this case, here's 1. I've got a hole here on the axis, but if I go up, I get a dot right here. So f of 1 is at 4. It's where the dot is, not the hole. Okay, find the values of x where f of x equals 2. Remember, this is the y value. So I'm going to look for a y of -2, and I'm going to go over and find the corresponding x. Okay. The domain of this one, the domain is the x values, right? So it looks like I start right here at -3, and I'm going to go along. Even at 1 here, I have a dot up here, so I keep going, and then I end here at 4. So my domain is everything, let's put it in interval notation, from 3 to 4, and I can't include the 3 because it's a hole, but I can include the 4 because it's a dot. So this would equal in set builder everything from 3 to 4, but I would not put that equal sign there. Here we go. Okay, the range is the y values. So let me get a different color here. So the y values looks like we start right here at this hole, and I go up, 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 until I hit 1, until I hit 0. And then I have a jump. I don't have anything in this gap. There's nothing here. And then I go from 1 all the way up, 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 till I get to 5. So the range is going to be from -4 to 0, and then from 1 to 5. So remember, the range is the y's, the domain is the x's. So the set builder on this one would look like this. Okay. All right, that's where we're going to stop for today. Hopefully that was helpful, and we'll continue on with some more information about functions next time. See you then.